Today, we're going to talk about something that honestly sounds like it's straight out of science fiction, but it's not. We're looking at how thermal cameras, combined with some seriously smart AI, could start finding cancer way, way earlier than we ever thought possible. So let's just start with the one number that really puts everything into perspective: 97%. That's the survival rate for breast cancer if you catch it at the earliest possible stage. But if it's detected late, that number just plummets all the way down to 27%. The stakes here are incredibly high, which is why everyone is in such a race to find a better way to detect it. So, what are we dealing with right now? Well, we have mammograms, which, involve radiation and can actually be less reliable for women who have dense breast tissue. And on the other side, you've got biopsies. They're invasive, they can be painful, and they force you into that long, anxious wait for the results. We can do better. We have to do better. And that's really the heart of our first topic, this ongoing race against cancer. The search for a new tool isn't just some lab experiment. It's about finding a whole new strategy for this fight. So, what if we could just change the game completely? Forget radiation, forget needles and scalpels. What if we could spot cancer just by looking at its unique heat signature? A method that's totally non-invasive, completely radiation-free. That idea brings us right here. Seeing with heat. We're going to break down exactly how this thermal imaging tech works and how it lets us see this invisible world of heat that could be the key to early detection. The science behind this is actually pretty simple and elegant. First off, cancer cells are just buzzing with activity. They have a super high metabolism, and all that energy generates extra heat. Then, to keep fueling that crazy growth, tumors build their own network of new blood vessels, which brings even more warm blood to the area. And finally, a special infrared camera comes in and captures all these tiny temperature shifts, creating this incredibly detailed heat map. And the advantages here are pretty obvious and pretty huge. It's completely safe. We're talking zero radiation, no contact at all. It's also way more cost-effective, which could make regular screenings much more common. And maybe most importantly, it works just as well with dense tissue, which is a massive hurdle for traditional mammograms. But of course, there had to be a catch, right? The problem is, these heat maps have incredibly low contrast. The temperature differences are so subtle that for the human eye, trying to pick out a tumor from all that background noise is, well, it's next to impossible. So if our eyes aren't up to the task, we need a new kind of vision. And this is where the hero of our story makes its entrance: artificial intelligence. Specifically, a type of AI called a convolutional neural network, or CNN. So what on earth is a CNN? Well, the easiest way to think about it is like a kind of superpower for seeing things. It's an AI that's built from the ground up to analyze images and spot these incredibly complex hidden patterns that our eyes would just skim right over. Basically, it learns to see what we can't. Okay, that sounds great, but there's another huge challenge. To get an AI to be an expert, you usually need to show it thousands, maybe millions of examples. And in the medical field, getting that many thermal images of tumors is really, really hard. So how do you train an expert when you've only got a handful of pictures to work with? The solution they came up with is just so clever. It's called image augmentation. Essentially, you take the few real images you have and you get creative. You rotate them, you flip them, you scale them up and down to make it look like they were taken from different angles. You can even add a bit of random digital noise to the picture, which sounds weird, but it actually makes the AI tougher and better at handling real-world images. And you can even use AI to create brand new, totally synthetic images to give the system even more to practice on. Now, finding the cancer is a huge step. But for a surgeon, what really matters is knowing exactly where that tumor begins and ends. And that brings us to the AI's next critical job: drawing the battle lines. This whole process is called segmentation, and it's basically like creating the most accurate map imaginable. The AI goes through the image, pixel by tiny pixel, and makes a call. Is this pixel part of the tumor, or is it healthy? Then other algorithms step in and use that data to draw a super precise, clean border around the tumor. That map, it becomes an absolutely priceless guide for surgeons and for planning the best possible treatment. All right, so we've got the theory, we've got the smart training methods, we've got the precise mapping. But at the end of the day, there's only one question that really counts. Does this thing actually work? Well, let's take a look at the results. So how did it do?
Well, when tested on a public dataset, the AI model hit a jaw-dropping 98.8% accuracy for just identifying whether cancer was present or not. Nearly perfect.
That's just step one, right? What about drawing that crucial map for the surgeons? The system scored 95% on precision. That means the borders it drew were incredibly accurate. And even when they combined different AI models into a kind of hybrid system, the overall accuracy stayed way up there at 95.7%. Look, these aren't just good numbers. These are the kind of numbers that could represent a genuine breakthrough. So, where do we go from here? Well, the next big steps are pretty clear. We need to build bigger and more diverse collections of images to make the AI even smarter. We need to make the AI's thinking process easier for doctors to understand and trust. And then there's the practical challenge of fitting this into the chaotic workflow of a real hospital. And of course, the ultimate dream is to expand this to help detect other cancers like skin or lung cancer. And this really gets to the true world-changing potential of this technology. Just imagine for a second being able to do an early-stage cancer screening in a remote village with nothing more than a special camera and an internet connection. This could totally revolutionize healthcare, bringing life-saving tools to people and places that have never had them before. Which really just leaves us with one last big question to think about. In this never-ending fight against cancer, as we're all searching for tools that are safer, faster, and available to everyone, could it be that a simple thermal picture seen through the eyes of an AI becomes our new best defense?